Students will be able to determine the domain and range of linear functions in mathematical and real-world problems, both continuous and discrete, and express it using inequalities. The first example that I'm going to work out for you today is going to be question number 1. The directions for question number 1 ask you to determine the domain and range of the following linear functions. We're asked to find the domain and range. Before we start the problem, let's talk a little bit about domain and range. Domain, by definition, is all possible x values. Look at your x-axis. I'm going to highlight it in green. It runs from left to right. On the left, the numbers are negative, they're smaller, and as you go to the right, the numbers get bigger. So when we're talking about domain, we want to say that it runs from left to right. The directions are going to ask you to write your answers as an inequality. When you write the domain as an inequality, because domain is the x, it's going to have the x in the middle surrounded by these inequality symbols. Because domain goes from left to right, the leftmost number is going to go here and the right number is going to go there, okay? So domain, all possible x values, domain goes from left to right. And when you're writing it as an inequality, it's gonna start like this. Range is all possible y values. That's the definition of range. If you look at the coordinate plane, the y-axis runs from bottom to top. All the negatives are at the bottom and the positives are at the top. So as you move from bottom to top, the numbers get larger. So for range, we're gonna say bottom to top. When you set up the inequality for range, because range is y goes in the middle, we put these symbols around it, and the first number will be the bottom number, the second number will be the top number. So range, all possible y values, the y-axis runs from bottom to top. So when we write our answer as an inequality, it's gonna look like this, okay? I'm gonna just erase everything that I have on my grid right here so I can start over with a nice clean page so there's no confusion. Okay, so number 1, we want domain. Domain is x. Start like this and put your symbols. Highlight your x-axis so that you know which numbers to pay attention to. Domain goes from left to right. This is my leftmost point. It doesn't go any further left than that, okay? It stops right here. That's my leftmost point. So we're gonna take that point and I'm gonna trace it down to my x-axis, and I am at -5. So this number is gonna go right here. The left goes here. On the left, I'm at -5. Trace this all the way to the right. Here I am, that's my rightmost point. It does not go past that. It stops here. Take that point and trace it up to the x-axis. It is at 3. So I'm gonna put a 3 right here. What this is saying is that my domain is between -5 and 3. But can it equal -5? Can it equal 3? That's the last thing we have to figure out. Sometimes you're gonna see points that look like this, which means it is not equal to. And sometimes you'll see an endpoint that looks like this. That means it is equal to. When you have a symbol that looks like this, it's unshaded, your inequality symbol is going to look like this. But when you have a symbol like this that is shaded, your inequality symbol is going to look like this. The difference between these two inequality symbols, this one is just less than, but this one is less than or equal to. When the endpoint is shaded in, it means it can be equal to that number. The motto that I use for this is no color no line. This symbol has no color, so this symbol has no line. This symbol has color, so this symbol has a line. Just remember, when there is no color, your symbol should have no line. No color, no line. Let's go back to our answer for domain and finish this up. If you look at the left side where the -5 is, does this symbol have color? Yes, it does. So does this symbol need a line? Yes, it does. Let's look at the right side where the 3 is. Does this symbol have color? No, it does not. So does this symbol need a line? No, it does not, because no color, no line. My final answer for domain is this. And we read this like this: -5 less than or equal to x less than 3. Essentially, the domain are all possible x values between -5, can be equal to -5, and 3, but it cannot equal exactly 3. All of these values between -5 and 3 is my domain. I'm going to erase my grid, and now I'm going to find the range. Remember that range is the y-axis. It runs from bottom to top. So when I'm looking at my numbers, I want to be certain that I'm looking at the correct axis. Now I'm doing range, so I'm looking at the y-axis. Start your answer with the y in the middle and put the symbols around it. Remember that range goes from bottom to top. So here's my line segment. This is the bottommost point. I'm going to trace that point over to the y-axis, and I'm at -1. So -1 goes here because that is where the bottom number goes. The bottom is at -1 on the y-axis. Now trace this point up to the very top. This is the topmost point. It doesn't go higher than this. It stops here. Trace that point to your y-axis, and we are at 3. Last thing we have to do is figure out which symbols need an underline. Remember, no color, no line. Look at the bottom, -1. Does this symbol have color? No. Does this symbol need a line? No. Now we're gonna move towards the top where the 3 is. Keep going. This symbol has color? Yes. So does this symbol need an underline? Yes. So my final answer for range is gonna look like this. We read this, -1 is less than y, less than or equal to 3. The range of this line segment is all possible y values between -1 and 3. It can equal 3 because this symbol is shaded, but it cannot equal exactly -1 because this symbol is not shaded. The next example that I'm going to work out for you will be number 16. The directions number 16 say to determine the domain and range of the following real-world graphs. Write your answers in words, not inequalities. So it's gonna be similar, but we're not gonna actually write out the inequalities. We're gonna describe it in words. Let me zoom in so we can first talk about what we have here in this graph. The title of this graph is quiz grade. So we're talking about grades on a quiz. My x-axis is describing the number of questions incorrect. My y-axis is describing the score on the quiz. So the more questions you get incorrect, the lower your score is going to be. Let's start with our domain. Domain is our x-axis. We're gonna trace the left point down to the x-axis. We're at 0. And the rightmost point is at 20. So the domain, the number of questions incorrect is going to be between 0 and 20. Look at the symbols. Do the symbols have color? Are they shaded in? Yes. So that means you can get 0 questions incorrect, and you can get exactly 20 questions incorrect. When we write our answer, we're not going to use inequality symbols like we did in number 1. We're going to express this in words. This is how we do it. Domain. All real numbers greater than or equal to 0 and less than or equal to 20. All real numbers greater than or equal to 0 or less than or equal to 20. The domain cannot be less than 0. You cannot get less than 0 questions incorrect. That doesn't make sense. You can't have, there's not negative questions on a test. You also cannot have greater than 20 questions incorrect because the quiz only has 20 questions on it, apparently. Therefore, the domain for this quiz is all real numbers greater than or equal to 0 and less than or equal to 20. Now let's do the range. I'm going to erase all the markings on this graph so that it's more clear. And I'm going to highlight my y-axis, which runs from bottom to top. Starting at the bottommost point, trace it over to the y-axis. We're at 0. That means the lowest score you could get on this quiz is a 0. And go to your topmost point. It's on 100, which means the highest score you could get on this quiz is 100. The range is looking like it's running from 0 to 100. Again, those endpoints are shaded, so it can equal 0 and it can equal 100. So we're going to write our range like this. All real numbers greater than or equal to 0 and less than or equal to 100. That's my range. And we wrote this in words, not in inequalities. The next example that I'm going to work out for you is going to be number 28. The directions for number 28 say to determine the domain and range for the following real-world situations. Express your answers as a discrete list of numerical values. You'll see why in a second. I'm going to read the word problem to you, and we're going to highlight what's important as we go. Number 28 says, the total cost in dollars to buy uniforms for the players on the basketball team can be found using the function C equals 25.50 U plus 7.50, where U is the number of uniforms bought. There are at least 5 players, but not more than 10 players on the team. That's all we're given. When you're given a word problem like this, the best strategy is to make a function table. The function table for this question is going to look something like this. We're going to have an input. We're going to have a rule in the middle. The rule for this function is C equals 25.50 U plus 7.50. And then that's going to give us an output. So what are the inputs? The input is the independent variable. The input is the U. U represents the number of uniforms bought. Let's think about what's going on here. We have a basketball team, and they're telling us that there are at least 5 players, but not more than 10. So we need uniforms for at least 5 people, but not more than 10. So 5, 6, 7, 8, 9, and we stop at 10 because there cannot be more than 10 people on a team. So those are my inputs. What I'm going to do with these inputs is I'm going to substitute it into the function rule where I see the U. So this first question is going to look like this. It's going to be C equals 25.50 times 5 plus 7.50. My next input is 6. So where I see the U this time, I'm going to put the 6. C equals 25.50 times 6 plus 7.50. So I'm just going to quickly keep going down and I'm going to substitute in all these inputs into the function rule. Now I'm going to use my calculator to figure out my outputs. From the home page, I'm going to go to the calculator. I'm going to type in my function, 25.50, parentheses 5, plus 7.50. That gives me 135. I'm going to copy and paste and just change these inputs. So for 6, 7, 8, 9, and 10. So these are all my inputs: 135, 160.5, 186, 211.5, 237, and 262.5. The reason I put 0.50 instead of just 0.5 is because we're talking about money here. We're ordering uniforms. When you go to the store, you don't see something that costs $160.5. It's $160.50, right? So that's why I put 0.50 instead of just 0.5. So now let's finish out the problem. It asks for a discrete list of numerical values. Domain is the inputs. So my domain is going to be 5, 6, 7, 8, 9, 10. That is my domain. Just list out your inputs. The range is going to be our outputs: 135, 160.50, 186, 211.50, 237, 262.50. Just list out all those outputs, and that is the answer for your range. That's it for this problem. The last example I'm going to be working out for you is going to be number 36. The directions from number 36 ask you to determine the domain and range of the following linear functions and equations. Express your answers as appropriate. I gave you a hint: graph the function and sketch it. So in number 36, they give us a function, f of x equals -10. Let's graph this in our calculator and see how that looks. Start from the home page, go to graph. F of x equals -10. I don't see anything. Let's zoom out. Menu, window and zoom out, and just click. There it is. It's right here at the bottom. It's gonna be crossing -10, but let's just be sure menu, trace, graph trace. Yeah, 0, -10. It touches the y-axis at -10. So keep that in mind when we draw our sketch. We have a horizontal line that goes across and it crosses the y-axis at -10. I'm going to sketch what I just saw on the calculator. I have a horizontal line and it touches here at 0, -10. So if domain goes left to right, and I see here a horizontal line that extends forever to the left, it keeps going off the page, out the room, out the state, keeps going forever to the left. Same thing on the right, it goes off the page, off your desk, out the room, out the city, forever and ever. What do we call that? We call that all real numbers. Sometimes you might see this symbol for all real numbers. The range is the y though. What possible y values can this graph take? Let's go back to our calculator and continue tracing. Let's kind of look at something here. As I go to the left, our x coordinates are changing, but look at the y coordinate. It's still always -10. See, we're at -29, -10. We're at -28, but we're still at -10. -10, -10. The y coordinate is always -10. When I come over to the positive side, I'm at 5, 6, 7, 8, but I'm still at -10 for the y coordinate. What does that mean? That means that because we have a horizontal line, the y coordinate is always going to be -10. If range is your y values, this horizontal line can only have one possible y value. What is that y value? -10. Therefore, my range can only possibly be one number, as we just saw. It's -10. Thanks for watching this video. For more videos like this, please hit the subscribe button. Also, follow us on social media or visit us at almightyalgebra.com.